today is probably the most important in terms of learning. By the way, if you're not doing anything at lunch, Just for Funk is playing at the Chapel Lanai, featuring Danny Dan on the drums. Wait, you gotta wait till he plays before you clap. Don't clap before you play.
Who else is featured?
Mr. Green, well it's actually Mr. Greenhill group, yeah, and then I'm playing, and Mr. Greenhill on bass, I play keyboard. Andrew Schweitzer on trumpet. Davey Tanaka on trombone. That's all I got.
Are you wearing any exotic costume again?
I don't wear exotic costumes at school. Okay, now on the test, you're gonna have 15 of these now. So this is the first time you got them. And then, like I told you yesterday, you gotta start categorizing them. Like, are we even? Oh, 1B, good. You guys, okay, 1B. Now sometimes you just have to like write out the first few terms if you don't know what's happening, man. Like this one, I don't know what the heck's going on, so I'm gonna write out the first few terms and maybe you can see what's happening. So if I plug in 1, 2, 3, 4, what do you get? Oh my gosh, you can plug in 1. Negative 1. Plug in 2. 7 pi over 4, tangent. Negative 1. If I plug in 3. Negative 1. You plug in 4. Negative 1. It's always negative 1, so the sequence converges to negative 1. The limit is negative 1. Because it's always negative 1. But some of you cannot even plug in 1, 2, 3, 4. Cannot even plug in 1. That's why you have a problem. C through J? That's not even funny. C. C sub n equal n over n minus 1 to the n. Okay, now when you look at this, what is the limit of the thing in the parentheses? 1, because the degree of the top and the bottom are the same, the coefficients, right? It's 1. However, then you're raising it to the nth power. So do not make this mistake. 1 to any power is 1. Because this power is going to infinity. Like, if this power was like 3, 1 to the third power, that would be 3. But this power is going to infinity. So you cannot do that. It doesn't work. So what you have to know in this problem, okay, let's go back to the second quarter. Does this look familiar? What is the limit as n approaches infinity of 1 plus box over n to the nth power? E to the box. Does that look familiar? Remember, second quarter we had to lomi and sometimes huli? And that's what you got to do in this problem, sister. So the first thing you do, see, you gotta massage this until it looks like this. So huli it first. So you huli it, but then you gotta put the negative over there in the exponent, right? Because negative 1 power moves flip over. And then what do? What can I do to make it look like that? You lift and separate 1 plus negative 1 over n, right? Look, a plus b over c. Isn't that the same thing as a over c plus b over c? We call that lifting and separating to the negative n. And then, is it almost looking like that? Almost, we're almost there. 1 plus box over n to the n. Yeah, but Mr. Buck, what do I do with the negative sign? You throw it outside there, because then you multiply the exponents. Come on, we did this not that long ago. So look, 1 plus box over n to the n. So as n approaches infinity, this thing here gets closer and closer to e to the negative 1. But then it gets raised to the negative 1. So what is e to the negative 1 to the negative 1? E. So the limit of this is e. Huli and lomi. I gave a problem like that in the notes. Oh, how come only 2 people noticed that? D. No! We talked about D. That's okay. No. Don't even worry about it. 2n squared plus 2n plus 1. You wish you did something this easy on the next quiz, which is probably Tuesday. So what's going to happen next week? Probably what? Quiz Tuesday, test Thursday. There's no more lectures already. We learned everything already. Okay, just look at inside. Okay, don't look at all the other stuff. Just look at the stuff you know. Look at the thing I circled. What's the limit of that thing? If the degree of the top and the bottom are the same, look at the coefficient. So what's the limit? 3. So this gets closer and closer to 3. So therefore, doesn't the whole thing get closer and closer to tan inverse radical 3 then? And is that a number we know? Tan inverse radical 3. Pi over 3 is the limit. Oh no. No! Yay! When you have a number to the nth power, we talked about this yesterday. Okay, let's talk about it again. When you have a number to the nth power, what kind of sequence is that? Geometric. Okay, and what did we talk about yesterday here? Maybe you guys should do this. If the common ratio is bigger than 1, remember? The limit is infinity. If the common ratio is between -1 and 1, it's 0. If it's less than -1, the limit does not exist. Mean girls. So all you gotta do is, you gotta figure out what is this number. Now you guys in chemistry already know natural log 2 is 0.693, right? Approximately. Anybody who's ever taken chemistry knows that, because from half-life and stuff like that, right? Carbon dating.
Yeah.
Okay, let's pretend we don't know that. 0.693 is between -1 and 1, the limit is 0. See, that's the difference between pre-calculus regular and pre-calculus honors. In pre-calculus regular, they just tell you what the number is. In honors, I told you yesterday, you gotta figure out what that number is. Okay, what is natural log E?
1.
E to the what power equals E? 1. And we know E is 2.718281828459045. So doesn't natural log 2 have to be smaller than 1 then? Because 2 is smaller than E. So even if you don't know it's 0.693, you know it's smaller than 1, right? But bigger than 0. Because we know natural log 1 is 0 because E to the 0 power equals 1, yeah.
Was that the Jackson, the 7th president one?
Yes. Do we have to ask at this point?
I was just recalling.
By the way, did you even tell your history teachers about, remember I told you John Quincy Adams used to pretend he was asleep and listen to the other people? When we studied ellipses. Remember how the sound goes up and then it goes to the other focus? John Quincy Adams.
Oh yeah.
Did you guys ever tell your history teacher that? For extra credit?
We didn't study him.
The 6th president. Don't you study them all? You skip some of them.
It kind of depends what
teacher is this that's skipping some presidents?
The iPad Central man.
Mr. Rapoon.
Yeah.
He's gonna hear about it. How can you skip? That's like in math. We're not gonna learn addition. We're only gonna learn subtraction, multiplication, and division. What the heck is going on in this school? Skip John Quincy Adams? What other presidents did you skip?
I don't really know because I don't know all of those.
Are we really doing? Come on, look, F. Come on, people, get real here. Get real. We're way past April 1st. Look, this is the kind of, if the degree of the top and the bottom, you want to get this kind because this is the kind you know how to do. If the degree of the top and the bottom are the same, then what? You look at the coefficients. What's the limit? -1/2. So that gets closer and closer to -1/2. Therefore, the whole thing gets closer to sine inverse -1/2, which is -pi/6. Because remember the range? What's the range? Okay, G, I'm assuming we're doing G. Oh my lord. Okay, this is like this problem. It's a number raised to the nth power. This is geometric. You just have to figure out, is the number bigger than 1, between -1 and 1, or smaller than -1? That's all you gotta figure out. Yeah, but Mr. Burke, can I use my calculator? No. Look at the unit circle. Okay, what is 1 radian? We talked about this in trigonometry. And you guys in physics, come on. 1 radian is approximately 57.3 degrees, right? Why are you laughing? So I have to show you. Okay, let's go back to physics. 1 radian. Let's do dimensional analysis on this. Yes. How do you convert radians into degrees? Degrees over radians, so the radians cancel out. But we know 180 degrees is equal to pi radians, right? So 1 radian is equal to 180 over pi degrees. Pi is a little bit bigger than 3. 180 divided by 3 is 60, so what? A little bit smaller than 60 then, right? But you want to be more exact, about 57.3 degrees. Oh gosh. Okay, what about at 45 degrees? What is the tangent of 45 degrees? 1. So if you had 57.3 degrees, what do you think? It will be bigger than 1 because when you get closer to the y-axis, tangent gets bigger, right? This tangent starts at 0 here, then it's 1, and then it gets bigger, bigger, bigger. So this number is bigger than 1, so therefore the limit is infinity. Whenever you have a number to the nth power, it's geometric. There's only 3 possibilities it can be. It's a 1 out of 3 chance. If you don't know, just it's either it does not exist, 0, or infinity. That's it. You guys are beginning scared. Good thing there's no lecture today. We'd be in a heap of trouble. Okay, so just keep moving on. H. Okay, yesterday as an example, didn't I do sine n?
Yeah.
Okay, and think of the graph of sine n. In fact, isn't this the first time we encountered Mean Girls? As the graph is going out to the right, is it getting closer and closer to something? No, it's just oscillating back and forth. It's not getting closer and closer to some number. So the limit does not exist. So I just changed this one to cosine. All hell broke loose. Okay, let's draw the graph of cosine. The limit does not exist, people. The thing just oscillates back and forth. If I wasn't so tired, I'd be angry. What did we learn? Did we learn yes or no? Did we learn n to the n fepal? If both the top and the bottom both go to infinity, to figure out which one goes to infinity faster, you use n to the n fepal. Okay, what is that? How do you classify? That's like n to the first. Which one is it? Polynomial. N to the first, n to the second, n to the third. You need more examples? N to the fourth. Any more? N to the fifth. This is exponential, like e to the n, 2 to the n, 5 to the n. Any more examples? This is exponential. So which one goes to infinity faster? Look, this is fast on this side. This side is fast. This side slow. So which one's going to infinity faster? The denominator, so the limit got to be 0. Because when you plug in a really huge number for n, the bottom is going to be way bigger than the top. Okay, enough of the jokes. And J. Okay, J is the hardest problem on this whole page right here. And you're going to see why right now. Okay, what time is it? We're going to run out of time. We're just getting out of number 1. Oh gosh, we are in a heap of trouble. Okay, so if you write out the first few terms, you get 1, then you get the square root of 2, the cube root of 3, the fourth root of 4, the fifth root of 5. Mr. Park, I don't know what's going on. Okay, now watch. This is a technique we use in BC calculus, okay? AB, we don't even get anything close to that. This is like n to the 1 over n power, correct? So, as n approaches infinity, this gets infinitely large. What about that? That goes to 0. See, now again, don't make this mistake. Anything to the 0 power is 1. Yeah, any number, any finite number to the 0 power is 1, but that's going to infinity. Infinity, you cannot treat infinity like regular numbers, because it's not a number. You know what I'm talking about? Like if this was If this was like 3, then 3 to the 0 power is 1. But this is not 3, this is n. N is going to infinity. You know what I'm talking about? Okay, so this is how we do it. So this limit is too hard to figure out. So instead of looking at the limit of this, we look at the limit of that. Okay, what do we call this box then? I want to find the limit of box. But it's too difficult, so I'm going to find the limit of natural log box. This is a technique in BC, you gotta remember that. Now, why would I look at natural log box? Because you can use your properties of logarithms. What can I do with the power? Cough it up in the front. So if you have 1 over n, isn't that like this? 1 over n is like that, right? Do I know what the limit of this is? N to the n fepple, they both go to infinity. Natural log goes to infinity very slowly. Here, let me draw the graph. Very slowly, but it does. N is polynomial. Well, just use n to the n fepple. Oops. Which one is going faster to the infinity? Polynomial or logarithm? Logarithm is the slowest growing one. So if the bottom is growing bigger, this limit is 0. So if the limit of natural log box is 0, it's getting closer and closer to 0, then what is the box getting closer and closer to? 1. Because natural log 1 is 0. Or here, e to the 0 is that. E to the 0 is 1. Okay, some of you better look at this. So instead of looking at the limit of the thing, you look at the limit of the natural log of the thing. I'm not going to take BC. Okay, what about L? Everybody here can do L. I don't think I discussed this yesterday. And this is going to be on the test.
Let's do L.
Give you L. Sin n over n. Okay, Mr. Park, we learned that one by itself, that one does not exist because it's oscillating, but now you keep dividing it by bigger and bigger numbers. So, even though it's oscillating like this, so you keep dividing it by bigger and bigger numbers. So what happens? It's oscillating, but since you keep dividing it by bigger and bigger numbers, the amplitude is getting smaller as it's going on to the right. So, what do you think the limit is? It's 0. Because look, sine always stays between -1 and 1, right? It oscillates. But then you're going to divide it by 100, then 1,000, then 1,000,000, then 1,000,000,000, then 1,000,000,000,000. It keeps on getting, even though it's oscillating, it still gets closer and closer to 0, so the limit is 0. Okay, thank God m is not on there. That's n to the n fepple, but n is n to the n fepple. That's just the reverse of this one. Look, the top is polynomial, the bottom is logarithmic. Polynomial grows faster, so if the numerator is growing faster than the denominator, what's the limit? It rhymes with infinity. It's infinity. And then O, everybody got O. You guys know why O is, the limit does not exist? Look at the graph. Tangent looks like this. Woo! 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 Is it getting closer and closer to anything? No! The limit does not exist. We'll have to keep going. That's why, if you knew what the graph of all of these things looked like, you could answer the question because you just think of the graph. But some of these, it's too difficult to draw the graph, so you have to use other techniques. But the ones where you know the graph, that's the one you just pounce on like a wounded wildebeest. Just pounce on it, just start tearing off flesh. Arrgh! Okay, number 2 to 4. What is it? I am not going to do number 2, that's an arithmetic. You just keep adding 3 to the previous term, it's arithmetic. Come on, just use the formula for that. Oh gosh. Okay, we only got 9 minutes left, okay. Number 3, let me, oh gosh. We'll come back to number 3, let's do number 4. Okay, I'm going to do number 4. Okay, here we go. Now we're talking. 0, 3. Now I'm going to teach you something. We didn't have time before, but now I'm going to teach you this. What is the explicit formula for this? So this is what you got to go, what goes through your mind. Is this arithmetic? No. Is it geometric? No. So now I gotta rely on my mathematical prowess. So I try to break it down. Okay, so this is 2 times 5, that's the first thing I think of. So 1 times 3, 0 times something, 3 times 7, 4 times 9. Do you see a pattern?
Yes.
So how do I, to keep the same pattern, it's 0 times 1. So what's the formula? How do you generate the numbers 0, 1, 2, 3? N minus 1. How do you generate the numbers 1, 3, 5, 7?
2n.
2n and adjust. Minus 1. There you go. That's your answer. You break it down. But Mr. Park, I have a hard time breaking it down. Yeah, okay. A lot of people do have a difficult time breaking it. Remember that answer now. So, is there like a mechanical technique I can use so that I don't have to break? Because Mr. Park, I'm serious. I can't do it. Okay, so yeah, you use the method of finite differences. So what you do is you look at the difference between these two terms. What's the difference? 3. What's the difference between these two? 7, 11, 15, 19. Is that constant?
Yeah.
No, it's not. Constant means it's the same. What's the difference? Now, then you look at the difference of the differences.
Yeah.
4, 4, 4, 4. Is that constant? Yes. If it takes 2 levels to get to the constant difference, then you know the formula is going to be second degree polynomial. It's going to be quadratic. So that means the formula is going to be an squared plus bn plus c. It's going to be quadratic. If it takes 3 levels to get to the constant difference, then it's going to be cubic. If it's just 1 level, then it's going to be linear. You know what I'm saying? If it's 10 levels, then it's going to be like some 10th power equation. Okay, but of course I wouldn't give you that because it would take long. But at least now we know it's quadratic. It's got to be something n squared. So how do I, now that I know that, what can I do? If I plug in 1 for n, a plus b plus c, you should get what? The first term, which is 0. If I plug in 2 for n, you get 4a plus 2b plus c. That's got to equal to the second term, which is 3. And then if I plug in 3 for n, 9a plus 3b plus c, that's got to equal to the third term, 10, and then you just solve these 3 equations. Now, yes, it's kind of a lot of work, but at least you don't have to like use your mathematical prowess anymore. You don't have to break it down. I know you guys can solve this, right? Okay, I'll just do it quickly. This minus this, 3a plus b equals 3. This minus this, 5a plus b equals 7. This will be, subtract again, 2a equal 4, a equal 2. Plug it back into there, so you get a equals, what? Plug it in there, b equals -3. And then plug these 2 back into one of these, probably this one, 2, -3, c is 1. Therefore, the explicit formula for this sequence is going to be 2n squared minus 3n plus 1. Isn't that the same thing we had from the first time? Yeah, it should be. But this is a mechanical way of doing it. This is called the method of finite differences. Okay, we got time for one more problem. I think we should do, yeah, why don't we do 4? Now you have to write, this is the explicit formula. Now you have to write recursive formula. Now, when you do this, this is what you do. A1 equal 0. Right? Isn't the first term 0? Now I'm going to tell you, every time I ask you to do this, and you're going to probably do this twice on the test, do what I'm doing now. Exactly. Don't even do it. Don't even think. A2 equal A1 plus something. Put parentheses there. A3 equal A2 plus something. A4 equal A3 plus something. A5 equal A4 plus something. Fill in those somethings and you should see a pattern here. Okay? So, to get the first term is 0. To get the second term, what do I have to add to the first term? What do I have to add to 0 to get 3? 3. What do I have to add to the second term to get the third term? 7. What do I have to add to 10 to get 21? 11. What do I have to add to 21 to get 36? 15. Is there a pattern to that, those numbers that I just wrote? Or these are just random numbers? There's a pattern! Okay, so now you just have to write it in the general case. Now, on the test, this is what the test is going to look like. I'm going to give you the recursion formula. You just have to fill in the box over here. So what you do is you do this. You do exactly this. Make sure you do 4. Because lots of times you can't tell a pattern from just 3 numbers. You need that big 4. Okay? Okay, well, what did we learn? What kind of sequence is this? 3, 7, 11, 15. It's arithmetic. Ooh, what's the common difference?
4.
4, so you write 4n, and then you adjust. Let's see if you can figure it out. Adjust. No. Minus 5. Isn't it minus 1? No, because in a recursive formula, the first term is given already. You got to start with the second term. See, if you plug in 2, you want to get 3. See? So if you plug in 2, 4 times 2 is 8. What do I have to do to 8 to get 3? Subtract 5. You guys understand that? In a recursive formula, you start by plugging in 2, because the first term is given. This is a recursive formula. Okay, just keep staring. Okay, the bell's going to ring in 1 minute already. Okay, so we didn't do B. I showed, okay, so when you do B, the explicit formula is pretty easy, okay? But the recursive formula, this is what you need to do right here. If you still can't do it on Monday, then we'll do it on the board. And number 3, all you got to do is you got to write out terms. Number 3, write out like the first 5 terms. Did you guys do that? And you still can't figure out the pattern? Okay, tell me what it is then. 3. Go. 1. Wait, read it off. 1/3. 1/7. 1, let me tell you, 15. 1/31. Okay, why don't we write that as 1 over 1? So the explicit formula is going to be 1 over something. Where have I seen these numbers before? You got to break it down, people. I'll give you a hint. These are all like 1 smaller than things you're supposed to know. Quick. 2 to the 1 minus 1. 2 to the 2 minus 1. 2 to the 3 minus 1. 2 to the 4 minus 1. Do you see a pattern in that, or these are just random numbers? 2 to the 5 minus 1. So 2 to the n minus 1. Okay, so I guess we have to raise the level of our mathematical prowess, people. Okay, that's it. And I guess we'll do that Monday. And I thought we were going to finish early.